Right now, as you're watching this, 40% of the large power transformers keeping your electricity running were manufactured in China. If Beijing decides to stop shipping replacement transformers tomorrow morning, here's what happens. Portions of the grid go dark for 18 to 24 months. Not days, months. And the terrifying part? Most people have never even seen one of these devices. They're the most critical component in the electrical grid and the most invisible. I'm an electrical engineer with 15 years in critical infrastructure. I've worked inside data centers and power facilities that depend on these systems. And what I'm about to show you isn't speculation. It's documented in federal reports and industry data. This is the story of how a single supply chain became a geopolitical weapon. And it starts with a device you've probably never thought about. Let me explain what a large power transformer actually does, because understanding this is critical. Electricity travels long distances at extremely high voltages, sometimes 345,000 volts or more. This minimizes energy loss during transmission grid. But your home runs on 120 or 240 volts. A power transformer is what steps that voltage down at substations. Without it, you can't connect the high voltage transmission grid to the lower voltage distribution system that feeds neighborhoods. Every major substation has at least one. Cities have dozens. Industrial facilities need specialized ones. And here's the critical detail most people miss. These aren't off-the-shelf items. A single large transformer can weigh 200 tons, cost $2 to $5 million, and take 12 to 24 months to build after you place the order. They're custom engineered for specific voltage levels, cooling requirements, and load conditions. You can't just swap one out like a spare tire. And that's where the vulnerability starts. Because there's essentially no stockpile of spares in the United States. In the 1980s, the United States manufactured most of its own transformers. Companies like General Electric, Westinghouse, and ABB had domestic production facilities. But over the last 25 years, something changed. Manufacturing moved offshore. Facilities closed. And today, the U.S. has almost no large-scale transformer production capacity. Currently, about 80% of the world's large power transformers are manufactured in Asia. China alone produces roughly 40% of global supply. South Korea and India make up most of the rest. The U.S. imports approximately 85% of the transformers installed in its grid each year. Let that sink in. 85%. Now, imagine what happens during a trade war, a geopolitical crisis, or as we saw in 2018, when tariffs suddenly make critical infrastructure components unaffordable or unavailable. In 2018, when the U.S. imposed tariffs on Chinese electrical components, delivery times for transformers ballooned from 12 months to over 20 months in some cases. Projects stalled, utilities scrambled. And then there's the strategic angle. In Ukraine, Russia specifically targeted electrical substations, not just to cut power, but to destroy transformers, because they knew Ukraine couldn't replace them quickly. When a transformer is destroyed, the replacement clock starts at 18 to 24 months. That's not a repair timeline. That's the manufacturing lead time. So let's walk through the scenario. What actually happens if China, whether through trade conflict, sanctions, or strategic decision, stops exporting transformers to the United States? First 6 months, existing inventory gets consumed. Utilities that planned maintenance now have to delay it because they can't get spares. The grid becomes more fragile. 6 to 12 months. Natural failures occur. Transformers age lightning strikes happen, equipment wears out. But now, there's no replacement supply. Utilities start operating in what's called run-to-failure mode. 12 to 18 months. Critical failures in major substations. Some areas lose redundancy entirely. Rolling blackouts become necessary to prevent total collapse. 18 to 24 months. Portions of the grid are operating below minimum reliability standards. Economic impact estimates range from $1 trillion to $2 trillion for an extended, large-scale outage. And it's not just lights going out. Hospitals, water treatment plants, data centers, communication networks. Everything depends on stable power. When the grid fails, modern society doesn't just pause, it stops.
In my book, The Invisible Infrastructure, I document a real incident that illustrates how fragile this system actually is. Not a catastrophic explosion, just an internal fault that took the unit offline. The facility had redundancy designed in. The problem? The backup transformer was also due for maintenance, but the replacement unit was stuck in customs because of supply chain delays.
For 72 hours, this facility operated with zero electrical redundancy. A single additional failure would have meant total shutdown. The root cause wasn't engineering failure, it was supply chain dependency. The transformer they needed was manufactured overseas, and during that window, they were one lightning strike away from catastrophe. This is what I call invisible infrastructure. Chapter 3 of my book covers the entire electrical supply chain and the geopolitical vulnerabilities I didn't have time to explain here. Link in the description. Next week, I'm covering submarine cables. If you want to understand the systems that actually run the world, subscribe. This is Global Blueprint. See you next Friday.